What is up, everyone? Welcome back to my YouTube channel. Today we're going to be talking about Gliese 667. So, you know about my exoplanet talks. Just like Kepler 444, this will be split into two parts. Just like before in Kepler 444, if you didn't watch it, or if you're new here, you might not know. But basically, this will be split into two parts. So this video, which is part 1, will explain all of the stars present in the triple star system of Gliese 667 with A, B, and C. Then part 2 will explain the exoplanets in Gliese 667, and there are 6 of them in total, so this will be in part 2. So part 2 will release sometime after part 1, and this is part 1. So let's go to Gliese 667's 3-star system. So what is Gliese 667? Like I mentioned, it is a 3-star system. It is a 3-star system. If we look at how far it is about 22 light years away from the Earth. And this is what it looks like. There's basically 2 stars orbiting each other in one barycenter if we turn on the orbits. So basically there's one barycenter where these 2 stars are orbiting, and that barycenter is orbiting another barycenter where these 2 stars are orbiting the barycenter, along with another smaller red dwarf star that orbits the central barycenter of Gliese 667. So first I'm going to go to the AB barycenter, which contains 2 K-type stars. So this is Gliese 667a, which is the first star in the first smaller barycenter. So it is a K3V star, which it's mostly a high-class K-type star with a temperature of about 4,730 degrees Kelvin and 6.12 AU away from the barycenter, taking 42.1 years to orbit the barycenter along with its other star over there. It takes 20 days to rotate an actual tilt about 14 degrees. It's about 2 billion years old. The entire system is 2 billion years old, making it much younger than our solar system of 4.5 billion years old. It is about 76% the size of our sun and 73% the mass of our sun. Its luminosity is just 16.8% our sun, meaning it's very dim, but not as dim as red dwarfs. The gravity is also 35.2 Gs as well. So this is what the star looks like. This is what it looks like when I see the surface. It's orangish because it's a K-type star. There's some small sunspots around it. And the surface up close. This is what the surface looks like on Gliese 667a. It's just a normal K-type star. Now it's time to go to Gliese 667b, which is the other star in that small barycenter which contains the 2 stars. It is a slightly dimmer K-type star, just being a K5V star with a temperature of 4,350 degrees Kelvin. Its actual tilt is just 2 degrees. Same major axis is 6.48 AU, which is also orbiting that small barycenter with an orbital period of 42 years. Rotational period is 19.6 days. And we know the age of 2 billion years because this system is 2 billion years. It's just 70% the size of our sun, or 974,000 kilometers, and just 69% the mass of our sun. It's only 5% the luminosity of the sun, making it dimmer than these Gliese 667a, and its gravity is 39.285 Gs, which is actually slightly more. So this is what it looks like. You can see some sunspots, and basically similar to Gliese 667a's surface, but slightly dimmer. And that barycenter is only 18 AU away from the central barycenter, taking 564.5 years to orbit that barycenter, which is the central barycenter right there. So let's go to the Gliese 667c, which is a red dwarf far away from the 2-star system of Gliese 667a and b. Gliese 667c is a high-class red dwarf star, or an M1.5V star, which it takes approximately 564.5 years to orbit the central barycenter of Gliese 667, and taking 105 days to rotate. Its semi-major axis from the very center is 82 AU, which is much farther than Neptune's orbit from our sun. The gravity is 49.2027 Gs, and it's the only star in that star system with exoplanets, having approximately 6. If you want to know about these exoplanets, stay tuned for part 2. Its luminosity is just 1% the brightness of the sun. The diameter is about 42% the size of the sun, and mass is just 31% the mass. Diameter is 42% the size of the sun, and mass 31% the mass of the sun. So this is what the surface looks like. You can see it's reddish because it's a dim star, being about 3,700 Kelvin, and its actual tilt is 18 degrees. You can see that's what the star looks like. You can see sunspots around it. So that's what the surface looks like. So anyways, thank you for watching part 1. If you want me to go over these other exoplanets, make sure to like and subscribe and turn on the notification bell so you can stay tuned for part 2 when I talk about all 6 of Gliese 667's exoplanets. Bye everyone, I'll see you later.